All right, so do me a favor, check out, we're going to start talking about the pink sheet first. So you had your SOL, congratulations. We're going to talk about that in a minute. Here we have our plan for you as far as what we go back and revisit. And the thing I need you to make sure you understand is this date here is your last test of the year. So on the 25th, 26th of May is when you have your last test of the year, and that's going to be a combination of circles, surface area volume, and some transformation stuff. Here is our schedule for the rest of the year. We're going to have a couple final exam review sessions, and what's interesting is sixth period gets, or our block days, our sixth period is going to get an extra day. You guys have an asynchronous day on graduation. All the teachers are at graduation, so you guys will be at home with work that I post on Schoology. And then we have 2 final exam review days that we're going to talk about. And then your final schedule, and it occurs to us that finals are new for you. You know, you guys have this post-COVID adjustment, for lack of a better word, and you didn't have a final last year, even though you were in a high school course in algebra. So what we want to do is make sure that you know what's going on. So if you're working on the warm-up, I'm going to ask you to put your pencil down, because I want to make sure that you're listening and understanding the things that I'm talking about now. Okay. So the way that we do finals in the high school, and it's the same way that we do finals across all of Fairfax County in the high schools. This is every high school does this same schedule. So on Monday, June 6th, you're going to come to school and you're going to have a short second period and a short sixth period. And then you're going to take your 8th period final. And then after your 8th period final, you're going home at 12:10. That's when our dismissal is. We're not feeding you lunch. So this whole week is early dismissal. Okay? So the reason why you have a second and a sixth period class is because with 4th period being our stingers, right? You don't have a final for that class, so that gives you an odd number of finals. So 8th period's odd man out, okay? So this will be the last time that you go to 8th period. So then on Tuesday, you come into school, the bus comes and picks you up, and then you have your 5th period final, and then you go right to your 7th period final, and then you go home at 12:10. It's a half a day. And then you come into school on Wednesday, you take your 2nd and your 6th period final, and then you go home and you eat lunch at home, and then you come in on Thursday and you have your 1st and 3rd period final, and then you go home. So during this time is when we're crazily grading your finals and figuring out your final grades, because school ends here. Now, on this last day, you do have that, like, I don't know, like a 10, 15-minute period where you come and any outstanding things that you need to turn in or whatever like that. But for the most part, your grades are already done and set, and we can have those conversations, and then that's the last day of school. So this is the first time you've had this as a finals week, where the bus, like, and it's organized through the county, so the buses pick you up and take you home on those early dismissal days. It is tricky because that's not the same case for the middle schools and high schools, so it kind of messes up the busing schedule, which is why it's countywide. Make sense? So for this warm-up, you have a review. What does this S and C and T stand for? Sine, cosine, tangent. Thank you for not saying sin. I really appreciate it. Sine, cosine, tangent. We have these 2 special right triangles, isosceles and equilateral. Would you please fill in your angles and your side ratios, and then would you and your partners please find the areas of these 4 triangles? On your mark, set, go. So when we talk about our ratios, sine, cosine, tangent, we have, whether you remember it by SOHCAHTOA or some old hippie, it's up to you, but remember that your sine of an angle is that ratio between the opposite and hypotenuse, cosine, adjacent hypotenuse, tangent, opposite, and adjacent. When we talk about our right triangles, we recognize that if each side length was x, our hypotenuse is x right 2, x root 2 in a 45-degree right triangle. If you don't remember these, you can always use Pythagoras and go back and derive them yourself. Our equilateral triangle, we can always drop an altitude, and we could say that if this x is equal to 1/2 of that side length, then our side length is double it, and our altitude is half of that side times root 3. This is going to become an important conversation in a little bit. All right, when I go to find my area of each of these triangles, so you can check your work with mine. The interesting thing is here, if I have 12, I know that x is equal to 12 divided by a square root of 2, and I did a completely crazy thing by not simplifying that radical. I left it in the denominator. So when I talk about the area of this triangle, it's 1/2 of this base times this height. So when I do 1/2 base times height, and I put that base and that height in, check it out, that root 2 ends up canceling out. So any efforts that I would have spent rationalizing that denominator were wasted. So I held on to that radical, and I went ahead and I figured out the area of this triangle is just going to be 1/2 times 144 over 2, and I get that 36 units. What's kind of cool is you can also think about when we did the area of a rhombus, 1/2 the product of the diagonals. A square is a rhombus. So if it has one diagonal 12, the second diagonal is 12 too. So the area of that square would be 1/2 of 144, and then I only want half of that. So that's kind of cool. Donovan, you're looking at me like I'm crazy. What about that one doesn't agree with you? Yeah.
The 12 over square root of 2.
Yeah.
How do you find that again?
So that's this conversation. That's this up here. Because if I have x root 2, then I know that this 12 is equal to my side length times root 2.
Oh, okay, yeah.
Are you with me there?
Yeah.
That 12 is equal to x root 2. So that's how I was able to find my 2 side lengths. Go ahead.
Can I put the area for, like, I think that's the height there?
So this is what I was talking about with how a square counts as a rhombus. So if you didn't want to go through figuring out your sides for your base times your height, you could have just said for the area of a square, it's 1/2 times the product of the diagonals. And then taken half of that, because I only have half of the square. Think about this related square, right? That square is a rhombus. Do you agree, Sumner? You have a furrowed brow.
If the area of a rhombus is 1/2 of diagonal times that diagonal divided by 2, isn't it just 1/4 of the diagonal times the diagonal?
Yeah. Yeah. That's it. All right, so for number 2, I had to use Pythagoras to find my height. Then I come down here, and I want you to notice, whatever math I do, as soon as it's time for me to start finding the area, Like, I'm pretty precise about how I do my math because I want to make sure that I leave a trail that I can follow in case I screw up. I will always take the time to say what I'm finding. Area is equal to 1/2 base times height. Sometimes I'll write the formula if it's been a while, and then I'll plug in what I know, and then that's what helps me figure out those calculations. Questions on 1, 2, and 3? So if you're sitting there with a blank paper, I don't understand why. We need to be working on and doing this math and keeping up. No opting out. No saying no thank you. Math is not a spectator sport. You don't pick up the pencil and do it, you're not going to learn it. All right, take a look at the next one, number 4. What I need you to do is put your pencil on that vertex on the top. I need you to get a straight edge out of the basket. I need you to draw yourself an altitude. Because any time that you are trying to find the area of a triangle, you have to have an altitude. And if you're not given the altitude, you got to draw an altitude. And drawing that altitude is what's going to get you started on where your first steps are. You're going to need to do some trig to figure this one out. Turn to your partner and figure out how to find how tall that triangle is. On your mark, set, go. All right, so let's talk about what I did. I created my own altitude, and then I had a 38-degree angle. So I knew the sine of 38 degrees is equal to my opposite over my hypotenuse. And then I went ahead and found my altitude. Once I had my altitude, that was all I needed. If I wanted to find the area, it was going to be, again, 1/2 times my base times my height. And then I was going to say, okay, 1/2 times this base. And then my height was equal to that altitude measurement that I just found. What questions? So you gotta be ready for that trig to come back in and for you to use it to figure out what you need. If you need to draw an altitude, if you need to draw a diagonal, if you need to draw something to help you with those calculations, rock on. Yeah.
You still need to solve the triangle.
So where it says solve the triangle, your next conversation would be to go ahead and then figure out your angles, and then you could repeat and figure out this side and keep going. We're not going to worry about that right now. We're going to keep moving on. Do you want to keep going? You do?
On this?
Yeah,
No,
okay.
that,
Okay.
that,
Yeah. We're going to keep going. All right. Next step. On the back of your warm-up, find the area of each regular polygon. Leave your radicals in simplest form. And then I'm okay with you dividing and conquering. I want you, for each regular figure below with the center C, go ahead and figure out the name of the shape, the measure of an interior angle, the measure of one exterior angle, and then the measure of this X, this degree measure here. All right, off you go. So when we talk about finding the area of each of these regular polygons, we revisit that whole conversation we had on the front about looking at our special right triangles and understanding our relationships between our sides. So for example, if this is 10, I know this is 5. So my area is equal to 1/2 times my base, which is 10, times my height, which is going to be 5 roots of 3. So I can call that 25 roots of 3. When I have my square, I can look here and I can say, okay, if this is 10 feet, If I wanted to do the whole 1/2 the product of the diagonals, I can do that. Or I could recognize that 10 is equal to my side length times square root of 2, because this is a isosceles right triangle. And that's again how I get 50. So either I get 50 by thinking about it as a rhombus or as length times width. And again, I don't necessarily worry about simplifying these radicals, because if that's just a working form of the number, a lot of times those radicals cancel out. It's easier to save yourself from that worry of doing that math. If I know what my height is, when I go to find my base, I know my height is equal to this side length times the square root of 3. So then I have my side length being double that. Now here I didn't have anything work out in my favor, so I did have to rationalize my denominator. No big deal. All right, so we want to make sure you have these next values down. And the interesting thing is, as we name and talk about a pentagon, heptagon, or hexagon, septagon, or heptagon, one interior angle, that's that n minus 2 times 180, right? But a lot of you have already figured out, let's just find the exterior angle, that's easier, 360 divided by my number of sides. And then my interior and my exterior angle are supplementary. This x value that we're going to be talking about next, that's going to be, we're going to call that a central angle, and that again is going to be the number of sides divided into 360. So you'll notice your exterior angle is going to be the same as that central angle. So you're going to want to get these values down, because this sheet is definitely going to help you with what it is that we're doing next. It's humid, so everything's sticking together. Yeah, we're going to talk about that at the end. So hold on to it for just a couple more minutes. All right. So here we go. So an honors extension that we haven't had a chance to talk with you about yet is this whole idea of finding area of regular figures. So when we find the area of a regular figure, it's interesting because we end up revisiting some circle vocabulary that seems weird to talk about it with a polygon. First of all, did you know that a polygon can have a center? So that center is defined as a point that's equidistant from each vertex. So then you're like, did you know that a polygon can have a radius? You're like, I thought that was just in circles. Nope. Your radius is going to be your distance from the center of your polygon to the vertex. So definitions, the center of a polygon is a point that's equidistant from each vertex. The radius of a polygon is going to be that distance. So you're like, all right, what's this next crazy word and how the heck do I say it? It's called an apothegm. Although I have heard some people call it the apothem. We like apothem. And your apothem is going to be the distance from the center to each side of your polygon. We never had that in a circle because a circle doesn't have sides. So our next conversation is, okay, what is this central angle? And you're like, that's another circle term. What the heck is it doing in a polygon conversation? Well, that is because that central angle, and that actually is what you just found the measures of, that central angle is going to be that measure created by 2 radii. So we can say that that is going to be 360 divided by however many sides that that angle has. That central angle is going to be my angle X. So it's cool to think about each one of these regular shapes can be divided into these isosceles triangles. So if I have an octagon, I can divide it into 8 isosceles triangles. Heptagon, 7, hexagon, 6, and so on. So in order to find the area of these things, what we're going to be doing is finding the area of each of these triangles and then adding them up. Before we can do that, we need 2 rules that says, okay, you're allowed to do that. First of all is our area congruence postulate. And what the area congruence postulate says is if 2 areas are congruent, then they have the same area. So what we can do is take a look at a shape like this, and if I can find the area of this triangle here, and I know that each of these triangles are congruent to it, I know that these congruent polygons are going to then have the same area. So I need that area congruence postulate to do what we're doing next. I also need this one that says, hey, you're allowed to add together. So the area of a region is the sum of the areas of its non-overlapping parts. So do you remember, I think it was in 7th grade when you had these composite figures where you first found the area of this, and then you found the area of this, and then you added them together? Do you remember doing composite figures?
Yeah.
Where if you don't know how to find the area of this shape, you can take any shape and divide it up into the polygons that you do know. So maybe you're like, I don't know how to find this shape, but I do know a trapezoid and a rectangle. I don't know how to find this shape, but I do know triangles and rectangles. So we want to have that idea of these composite figures of where I can divide a shape up into what I can do, find those areas, and add them all together. All right. These next 2 conversations are for the people that love formulas. Because if you're a formula person or a concept-driven person, it's nice to know where these formulas come from. All right, are you ready for this? Find the area of an equilateral triangle with 12-inch sides. Go ahead on your paper, sketch an equilateral triangle. And if I have 12-inch sides, go ahead, drop an altitude. Your area is equal to 1/2 of your base times your height. Take a minute with your group mates. Figure that out. Go. So if I know my area is 1/2 times the base times height, and I heard a question, is it 1/2 times the base and 1/2 times the height? Nope. No distributive property. They're all factors that get multiplied together. 1/2 times base times height. Nobody cares what order you multiply them in. I know my base is 12 because it's an equilateral triangle with 12-inch sides. So we need to make sure that we understand that that whole distance is 12 and that each of these sides is 6. So 1/2 of 12 times 6 root 3, and I got 6 root 3 because I know it's a 30, 60, 90 triangle. 6, 6, 6 root 3, not a problem. Put it in, left it in radical form, no big deal. Everybody okay with that? This is the formula for the area of an equilateral triangle. And if I want to talk about where that comes from, instead of calling this x, 2x, and x root 3, I need to think of this as side, 1/2 of the side, and this is going to be 1/2 of my side times the square root of 3. So when I put those values in, my area is equal to side squared times root 3 over 4. Let me ask you something. Do we get the same answer?
Yeah.
Yeah, because 144 divided by 4 is 36 roots of 3. So if you are a formula memorizer, feel free to pay attention to this formula. The area of an equilateral triangle is 1/4 side squared root 3. I got to be honest with you, I'm not a fan of formulas. I don't think I can remember one more thing. So if I keep track of 1/2 base times height, I can find it just as easy. Totally up to you. Sound okay? All right. On to our next side. A regular octagon is inscribed in a circle. So when we talk about what does it mean to be inscribed, what we're talking about here is each of these vertices is on the circle. That's what inscribed means. It has a radius equal to 1. Find the area of the octagon. So here's our plan. Our plan is to find the area of one of these triangles, recognizing that there's 8 of these triangles in this octagon. 1, 2, 3, 4, 5, 6, 7, 8. So if I find the area of one of these triangles, I can find the area of the entire shape by multiplying it by 8. Everybody good with that? All right, let's do the easy stuff first. Ready? Our radius is equal to 1 unit. That's easy. Our central angle is going to be 360 divided by however many sides I have. So 360 degrees divided by 8. What is the measure of our central angle? 45 degrees. So this central angle has a measure of 45 degrees. So whenever I do one of these, I'm going to take the time and I'm going to draw the isosceles triangle that I'm working with nice and big so that I can find the area of that isosceles triangle. And step 1 is to figure out what the length of my height of my triangle is, which also happens to be my apothem. Here it is here. That is my distance from the center to the side. If I know I have side lengths of 1, and I know I have a central angle of 45 degrees, what I'm going to do now is break down and use my trig to help me figure out what the measure of my apothem is. If I divide 45 by 2, I know that this angle is 22.5 degrees. Is this angle here? And I know that this angle here is equal to 67.5 degrees. How did I get that number? Yeah. It's the complement.
Disclosure. Does the apothem bisect the central angle?
Yes. All right. So when I want to find out, I need to use some trig. Which angle do you want to use? 22.5 or 67.5? You get a choice. Which one? Call it out.
22.
I heard 22. So if I'm looking for this angle length, is that my opposite or adjacent to 22?
Adjacent.
It's adjacent. So is that sine or cosine?
Cosine.
So the cosine of 22.5 is going to be equal to my adjacent over my hypotenuse. The cosine of 22.5 is going to be equal to my adjacent is my side that I'm looking for. That's my x. My hypotenuse is equal to 1. Oops, 1. So the cosine, I'm going to go to my calculator. I'm going to check my mode. Don't forget, a couple of you came back from your SOL and said, oh no, I think I forgot to check my mode. Make sure you're in degrees. And then you want to ask for the cosine of 22.5 degrees. And that's going to give you a height of your triangle as 0.92. So your x, your apothem height of your triangle, is going to be 0.92 units. All right, now I need to figure out what this value is. I need to figure out what half of my base is. So I'm going to need some more trig. Do you want to use the 22.5 and use sine? Or do you want to stick with cosine and use 67.5? Call it out. Which angle do you want to use?
22.
22.5. So we're going to stick with that, and now we're going to talk about the sine of 22.5 is my opposite over my hypotenuse. So the sine of 22.5 is equal to this y value that I'm looking for over 1. So now I'm going to go to my calculator and ask for the sine of 22.5. And that's going to tell me that half of my base is 0.38 units. If that's half of my base, how do I get my whole base? Just multiply this by 2. So my whole base is going to be equal to 0.77 units. And here's why I wanted my base. Because now I'm finding the area of this isosceles triangle. So my area is equal to 1/2 times my base times my height. My area is equal to 1/2. I just figured out my base was this. And my height is my apothem. I still have this value in my calculator, so I'm just going to leave it there, times 0.92 times 1/2. And I end up with the area of that isosceles triangle is 0.35 units squared. Take a minute, please, and show your partner what isosceles triangle we just found the area of. Show your partner. Where's the isosceles triangle that we just found the area of? I want everybody to point to it. This guy. Why do I want his area? True or false? His area is the same as all of these other guys.
True.
True, because they're all going to be congruent, right? So if I want to find the area of the octagon, what do I do? I have it already in my calculator. Times 8 So this area of this octagon is equal to 2.82 square units. Those two rules that I have for area, if the area of this guy is whatever it is, I know the area of all those guys is. So 0.35 for this one, for you and you and you and you and you and you and you too. And I can add them all together to figure out the area of the octagon. Now let's go back to that other formula that we didn't talk about. This guy. The area of a regular n-gon with a side length of s is 1/2 the product of the apothem and the perimeter p. So let's talk about that. If this is my center and this is my radius and here's my apothem, if the area of this triangle is 1/2 times my base times my height, and I know that my height is the same as my apothem. Do you see how this base, your perimeter, is equal to the number of sides times that base? So when we talk about this area, if I'm looking for the area of the whole triangle, it's times that number of sides. Here's my B, and here's my N. So that's how I get 1/2. And instead of writing my B and N, I'm going to write my P. Instead of writing my height, I'm going to write my A. So 1/2 of my perimeter times my apothem. Again, I don't have room in my head for another formula, but if you do, there it is. What I would rather do is find the area of one triangle and multiply it by however many I have. With your group mates, go ahead and figure out the area of these two regular polygons. Go.
Back to the formula.